This is for the Algebra 2 Honors 9.8 lesson, and we're going to first look at 2a and 2c where we're evaluating each of these expressions. So the first one here is secant squared 45 degrees minus tangent squared of 45 degrees. Secant is the reciprocal of cosine. So before we can find secant, we need to find the cosine at 45 degrees. So here, cosine is root 2 over 2. If cosine is root 2 over 2, the reciprocal of that is 2 over root 2. And then we're squaring that. Tangent squared of 45 degrees, well, tangent is sine over cosine at 45 degrees. Sine of 45 degrees is root 2 over 2, but cosine of 45 degrees is also root 2 over 2. So if we did sine over cosine at that spot, we would just get 1. And that's also squared, but that's not going to make a difference because it's just 1 squared. So if we evaluate that, here we get 4 over 2 minus 1. 2 minus 1 is 1. Let's also look at this one, cosecant squared of 7 pi over 4. Cosecant is the reciprocal of sine. So if we're at 7 pi over 4, sine is negative root 2 over 2. So cosecant is the reciprocal of negative root 2 over 2. So it'll be negative 2 over root 2 squared minus cotangent is the reciprocal of tangent. So we know tangent is sine over cosine. So if we're finding cotangent, we're finding cosine over sine. So at 7 pi over 4, cosine is root 2 over 2. Sine is negative root 2 over 2. So it's the same value, but it's a positive divided by a negative. So we get negative 1 and then squared. So evaluating this would be positive 4 over 2 minus negative 1 squared is 1. So we get the same thing we got here, 2 minus 1 is 1. So it turns out that secant squared minus tangent squared is an identity, something that's always true. Secant squared minus tangent squared equals 1 is an identity. So secant squared theta minus tangent squared theta, regardless of what angle you're at, is always going to be equal to 1. Same goes for cosecant squared theta minus cotangent squared theta. That will also always be equal to 1. So we'll be using these identities in proofs. We can rewrite these identities in many ways. So variations on the Pythagorean identity, secant squared theta, if we isolate it and we move the tangent squared over, we can write it as 1 plus tangent squared theta. If we want to isolate tangent squared theta, we can subtract 1 and write it as secant squared theta minus 1. These are all just variations because we're just rewriting this same equation. C and D are variations on this. If we isolate cosecant squared, we can add the cotangent squared to the other side. Or if we isolate cotangent squared, we can subtract 1. So we'll be using these variations on the Pythagorean identity on the back of 9.8, which is the next video.